This is a fourth practice problem for your exam 4 or your final exam. Again, it's a fluid pressure problem, but this one involves a dam tipping due to the fluid or a gate opening due to the fluid. These show up from time to time. Let's talk about it. So you remember earlier in statics when we did friction problems, we talked about tipping or slipping. And if you build what's called a gravity dam basically relies on its own weight to prevent water from escaping. And technically speaking, if that dam is relatively high with a narrower base, it actually could tip too. And this is really like the retaining wall problem. I mean, all of us have seen retaining walls built to hold back soil, but then that soil gets saturated with fluid, and you end up with a fairly high force on that retaining wall and not a wide enough base. And you see these retaining walls that are tipping in a tipping mode. And so this is not an uncommon problem. So this is a concrete dam. This is artificial. It's just 2 foot wide. It should be much wider, but 2 foot wide, 10 feet high, 10 foot long. So this concrete wall has a weight that's equal to 10 times 10 times 2. The specific weight of concrete is about 150 pounds per cubic foot, so about 2.5 times the density of water. And so the weight of this dam is about 30,000 pounds. So at what depth of the water? So you have a rising water level. At what depth of water will this dam or wall tip? And we're going to assume no slip. Slipping actually is a potential mode too, but we're going to just looking at the tipping mode. So we'll let the depth of the water be H. The pressure at the bottom is gamma H. The location of FR is 1/3 H. So FR is 1/2 base times height times the width. So 1/2, the base is gamma H, the height is H, the width is 10, and it acts at H over 3. So if you sum a moment about point B, you have FR times H over 3 tipping one way. And then you have the 30,000 pound weight of the dam times its moment arm, which is 1 foot the other way, preventing the tipping from occurring. And so the only number you don't know is H. And so you end up with an H cubed is equal to 288.5. And so our H is 6.61 feet high. And so as our water is rising, when our water level gets to 6.6 feet, 6 2/3 feet, basically, that's when our wall will be on the verge of tipping. If the water continues to rise, then the wall will tip. That's a dam tipping problem. Sometimes the moment of the FR about that corner is called an overturning moment. And I think you had a homework problem like that. So the overturning moment of FR is FR times its location, about the point of interest. The second problem we're going to work along these lines is a gate opening problem. And these occur again sometimes in fluid pressure problems. And so this is a gate ABC that pivots at B and is restrained by a stopper at C. There's a rising fluid level H, and this distance is 4 meters here from C to B. There's a rising water level, and actually when the water gets high enough, this gate will open automatically due to the water depth. And so the question is, at what H does the gate open? Well, basically, it opens, so the FR is 1/3 of the way up. So the FR is 1/3 H. And so once FR reaches the pivot point at B, which is 4, then H is 12. And so once H reaches 12, the resultant force is exactly at B, So the gate is on the verge of tipping or the verge of opening. And once our water level gets deeper than 12 feet, then the gate will open. FR will be above the pivot, the gate will pivot open, and the water will empty at that point. And so that's a gate opening problem, not an uncommon problem that happens from time to time.